Hello and welcome to the Elastic Collisions video tutorial. Here we have a golf ball heading towards a basketball, and we're going to solve for the final velocity of that golf ball after the collision. The first thing we're going to do is we're going to redraw this picture in a simpler format. So instead of golf balls and basketballs, we're just going to draw boxes. These boxes represent the basketball and golf ball before the collision, and this represents the golf ball and basketball after the collision. We're going to add velocity vectors to anything that has velocity. The basketball does not have velocity. The golf ball does, to the left. The basketball is moving to the left after the collision. And the golf ball, it does not say which way the golf ball is moving, but when a smaller massed object hits a larger massed object, the smaller massed object bounces backwards in an elastic collision. So feeling that's the right answer. And we'll be able to check that at the end of the problem. What we're going to do is we're going to put the masses in these boxes. So 0.625 kilograms for the basketball and 0.045 kilograms for the golf ball. And then after the collision, they did not change mass, so just the same numbers. Next, we're going to add velocities by their velocity arrows. So this is 2 meters per second for the golf ball. After the collision, the basketball is moving at 0.027 meters per second, and the golf ball is unknown, so we're going to show that it's unknown by calling it v2. Alright. We know that the momentum before collision equals the momentum after collision, so pi equals pf. So momentum is mass times velocity. So that's the mass and velocity of the first object, v1. So that's this. And we need to have the momentum of the entire system. So we're going to add the mass times velocity of the second object, the golf ball. And this is the momentum before the collision. So this will equal the momentum after the collision. The reason we want to put the problem into this format is now we can take each box and move each box one by one into the appropriate term. So 0.625 times 0 velocity minus 0.045 times 2. And that's a minus because we'll just do it this way, plus -2. It's the same thing, but just to keep the negative where it goes, it's the negative velocity because the golf ball is moving to the left, equals 0.625 negative 0.27 plus 0.045 times v2. Alright, so the first term is 0. The second term, well, that's going to be a minus now, so that's going to be 0.045 times 2, which is 0.09, so negative 0.09 equals 0.625 times 0.27 equals negative 0.169, just round a little bit, plus 0.045 v2. Alright, so you're going to take this number, the negative 0.09, and add this to it, just bring that to that side. So 0.09 negative plus 0.169, so 0.079 equals 0.045 v2. So to get v2, you're going to just take this number and divide by that number. So divided by 0.045 gives me 1.7 and then 5 repeating, so 1.76 meters per second. Now this answer is positive, which implies that the velocity is to the right, which is just what we drew, so we were correct when we put that there. So we'll say, because it asks for directions to the right. Thank you for watching the Elastic Collision video tutorial.